Hey guys, so today we're going to look at whether or not we are multiplying and dividing in scientific notation via word problems. And all you have to do is continually ask yourself, am I doing something over and over and over again, or am I breaking something down into tiny pieces? Obviously, if you're doing something over and over and over again, you're going to be multiplying. If you're breaking something down, you're going to be dividing. If you can do yesterday's skill, you can do today's skill, as long as you can figure out the operation. That's the hardest part, figuring out the operation. So let's look at this first one. A new wildlife refuge is being set aside from a rectangular section of wilderness. Its dimensions are 5 times 10 to the 5th meters by 4 times 10 to the 4th. Find the area of land in square meters. Well, the first thing I heard was rectangular, so I'm going to go ahead and draw myself a nice little diagram. And it told me my dimensions were 5 times 10 to the 5th, and 4 times 10 to the 4th. And it's asking me to find the area. So I'm thinking to myself, area is length times width. So this has to be multiplication. So I'm going to go ahead and set up my problem. 5 times 10 to the 5th times 4 times 10 to the 4th. Now, it becomes super easy. Multiply your coefficients and add your exponents. Remember, we follow our math rules when we're multiplying and dividing. 5 times 4 is 20. And then if I add my exponents, I get 9. Now, something should be screaming out at you. We're not done because our coefficient is not between 1 and 10. So I'm going to remember my good friend Lars. And I know there's an invisible decimal here at the back. I'm going to move it in one spot, and I'm going to add 1. So this answer here is 2 times 10 to the 10th power. Let's do another one. The total number of votes in the presidential election was 6.3 times 10 to the 8th. However, only 3 states submitted votes. How many votes did each of the states submit, assuming that they submitted the same number of votes? Well, I have a total, and I know that I have 3 states that submitted votes. How many votes did each of the states submit, assuming that they submitted the same number? I know that this is division because I'm breaking 6.3 times 10 to the 8th down into tiny little pieces, 3 pieces specifically. So let's set this up. 6.3 times 10 to the 8th divided by 3. And remember, there is no exponent, so it gets an exponent of 0. Now this becomes easy. Top in, bottom out. 3 goes into 6 twice. 2 times 3 is 6. Subtract, and left with 0. 3 does not go into 0. Bring your decimal up, and bring your 3 down. 3 does go into 3 one time. I'm left with 0. So my new coefficient here is 2.1 times 10 to the, and again, if I'm dividing, I subtract my exponents. 8 minus 0 is 8. 2.1 times 10 to the 8th power. Let's look at a couple more. All right, one thing I want you guys to think about is whenever you guys hear the phrase, how many times greater, that always, always, always means divide. Okay, so for example, if I were to tell you how many times greater is 40 than 5, that's saying how many times can I count by 5 to get to 40? In other words, 40 divided by 5 is 8. So 40 is 8 times bigger than 5. How many times greater? Always division. Let's look at one. There are 8.6 times 10 to the 4th birds in City Park. Of those birds, 3.2 times 10 to the 2nd are egrets. How many times greater is the total population of City Park than the egret population? Well, again, how many times greater, that immediately tells me I'm going to divide here. So the large number goes on top, 8.6 times 10 to the 4th, divided by 3.2 times 10 squared. Now, divide your coefficients. Top in, bottom out. 8.6 divided by 3.2. Now, since these are both decimals, I'm going to take my divisor, and remember this from math intervention yesterday, and move my decimal until the end to create a whole number. And whatever you do on the outside, you have to do on the inside. So now this becomes 86 divided by 32. All right, let's divide this out. 32 does not go into 8, so I'm going to go ahead and put a 0. It does go into 86 3 times. 3 times 32 is, 2 times. That's 2 times. 2 times 32 is 64. If I subtract down, 6 minus 4 is 2, and 8 minus 6 is also 2. 32 does not go into 22, so I know I have a decimal I can bring up and add a 0. Whew, this is going to be a long one. 32 does go into 222, 1, 2, 3, 4, 5, 6 times. 32 times 6 is 192. I'm going to have to do some borrowing here because I can't take 2 away from 0 or 9 away from 2. So I have to go all the way over here, change that to a 1, change that to a 12, and then change that to an 11 again, and now I'm left with 10 over here. 10 minus 2 is 8. 11 minus 9 is 2. 32 does not go into 28, so again I'm going to add another 0. Whew, this is a tough one. 32 does go into 280, 1, 2, 3, 4, 5, 6, 7, 8. 8 times. 8 times 32 is 256. We're actually going to stop there, guys. That is a really long division problem, which is not actually the focus of today's lesson. So I'm going to stick with our coefficient being 2.68 times 10 to the second power. Again, if you can divide, if you can multiply, if you can figure out what operation you're using, you can do this skill. Let's practice.